thank you everyone for coming. It's a great place to be. I wanted to start with a quick survey. How many people have been in wireless for more than 15 years here? Okay, it's kind of scary. How many people in wireless for less than 5 years? Okay, well, just to let you know, I always tell my friends there's got to be an easier way to make a living than selling wireless, so just heads up. What's that? Yeah, I would say there's an easier way to make a living. This has been one of the funner trips I've had, actually, making wireless connectivity work and bringing indoor location on par with GPS and all that stuff. I don't think I would do anything different. But anyway, today I'm here to kind of talk about this journey to where I saw AI and wireless kind of crossing. So today I'm going to talk a little bit about the journey, and then I'm going to talk a little bit about the data science and how it really applies to wireless technology. You know, for me, this journey personally started when I started seeing wireless and AI cross. It actually started with my aerospace adventure back in the early 2000s. For those of you who remember back in those times, that was really about the transition from all these autonomous APs moving to controllers. We were trying to help enterprise IT guys manage thousands of APs and thousands of wireless users. It was kind of during that phase when I started to realize the power of AI, because in addition to doing all this wireless connectivity stuff, back then I was also working on Wi-Fi location. I don't know if you guys remember that. Remember location, healthcare guys. About the only people who really cared about it was the healthcare guys. But when I was working on that problem, one of the things I realized is when you did these location stuff, you had to do these site surveys. You had to basically go learn this path loss model, right? You had to go figure it out. But I started to realize that problem could be solved. The problem back then is we didn't really have the technology, right? I was working on these 1U Linux boxes and I really couldn't implement all the algorithms I wanted to. And at the time, it wasn't that important. We had to sell Wi-Fi. Location was kind of a sideshow, and we kind of moved on. And I really didn't think I'd live, but what I did realize is that, hey, the problem could be solved. What I didn't think would happen, I didn't think I'd live long enough to see it. And that's the problem with getting older. The key to the game is live long enough and everything will finally happen. But what did happen was, for those who remember around 2007, we saw the Amazon guys come out. Compute power was no more like problems. Like, as long as you had the money, you could buy as much compute power as you wanted. The other big thing for me is when I saw Watson. I don't know if you guys remember IBM Watson in 2011. IBM actually built a piece of software that could play Jeopardy World Champions, right? And they built this piece of software that could actually answer questions on par with those guys. That's when I realized, the technology is available now to actually build a virtual assistant that can actually answer questions on par with a wireless domain expert. And so that was kind of where I started to get the thought of, yes, this will actually work. When you look forward in anything, the other thing I will tell you, I've actually went to VC dinners about all this AI stuff. Believe it or not, there are quantum computing startups right now. If you look in your Gartner Magic Quadrant, they're in the hype cycle. These are really fun things. So my next goal is to see if I can live long enough to actually build something on a quantum computer. At that point, things are going to get interesting. So that's kind of the journey how I got here. Now, if you decide you want to do it at home on your own, there's a couple of key ingredients when you want to build your own virtual assistants. First, you have to raise about $50 million. So go get that done. Get a little pile of money out there. Then you need to hire a bunch of wireless domain experts, people like yourself. So you have to get a couple wireless domain experts on board to actually know what they're doing. Second, you have to go find some data scientists. That's not as easy as you think it would be, trying to find people who understand math and statistics and understand wireless. That's a little tricky. And the third piece of the ingredient is really getting what I call a modern cloud stack. This is actually critical at this. When you actually look at, one of the things we're moving from, when I did aerospace, that was a very embedded software architecture, right? We're putting software on controllers, shipping them out. It took us months. Every time we want to add a new feature, it'd be 12 months, 18 months before I could get a new feature out. With these new cloud stacks right now, we basically release features every Wednesday. So when you're building this new virtual AI assistance, you really got to be innovating every week. And so this is the other key part of the solution. Now, when you look at the IBM Watson team, those guys basically took 3 to 4 years to go build that piece of software that could play Jeopardy. I feel like we are on the same mission, right? You know, I am trying to build a virtual assistant that can start to answer questions on par with the wireless domain experts. We've been at it about 3 years. The journey actually started back in 2015, right? The first part of the journey was really getting the data that we needed. Took us about a year to get all those pieces of the puzzles down. The other second part of the year, in 2016, that year was really dedicated to building all these metrics and classifiers that you would understand as a domain expert, right? We had to get this data into more of a structured format. And then the third key part is really the data science toolbox, you know, and that's what we've been working on for the last year or so. And we're now getting to the point where we take the data science toolbox, we've combined it with natural language processing, which kind of puts a face in all this and helps you sort through the data that starts to bring this virtual assistance to life. So when you look at the beginnings of this, see my other survey questions. Now they warned me this is a beer crowd. How many winemakers do I have out here? Okay, so you come see me after the show. So I make 1 barrel of wine a year. You know, and when you think about plan Bs, I will just warn you, chemistry is no easier than wireless. Winemaking is probably on par with wireless. You never know exactly how it's going to turn out. You think you could figure it out, you can't. But similar to making, data, your virtual assistant is only as good as the data you get. And some people ask me, he's like, Bob, why did you build an AP? And the reason build an access point was I needed the data. I needed to make sure I can get the data I wanted out of the edge, right? Because that is the source of truth. And I also want to get data from these mobile devices that are out on the edge. And when you dig into it, there's really 2 key components to doing this. One is kind of what I call synchronous data. And this is kind of the information we're all familiar with, right? Every 10 seconds we send back some information from the AP to kind of see what's going on out in the world. The other key to this is that, which is not in most of the products out there, is this asynchronous data. And this is really user state data, right? This is basically what enables things like dynamic packet capture, right? Because you have to do that right at the edge. I can't ship all the data back. I only want to ship the data back that is relevant when something goes wrong or something. And that requires you to have asynchronous state events outside of there. And probably the other key part of looking at this data source is, if you look at the convergence of Wi-Fi and BLE, you know, on the BLE side, we're starting to put more mobile SDKs down on the client. You know, it's happening right now in the B2C customers. All our customers who are building guest experiences, they're deploying all these mobile apps down to their guests. When you look at the enterprise space, enterprise employees are looking a lot more like customers too, or a lot more like consumers. And so this is another source of data that we're going to start seeing coming to the enterprise space when we start to get more visibility from the actual end user device and what's going on at that piece. So that's another key part of the data source being integrated into these type of solutions. So after you get past the data, this is the key part of what I call metrics and classifiers. And when you look at it, there's 2 key words here, real-time and user. And when we started the company, there was a lot of debate about real-time versus batch. You know, Bob, why can't we do this in batch? I really can do this with Spark. Why do I need to use Storm? The key part is if you want to be proactive, you have to process the data as it comes in, right? You cannot just put it in batch and try to process it an hour later. If you want to be really proactive, you want to process this as soon as the data come in. And this is what really enables hospitality customers, right? You know, I want to be able to figure out if that person's having a problem before he calls the front desk. The other key part of this is getting down to the user state. You know, back at Airspace, I was really here to help you manage APs, right? I was basically, you're doing a lot of APs. It was really about helping you manage the hardware. The real paradigm shift here is you really need to start managing the user experience all the way from the device, all the way to the internet. Right? And that is a key part of making sure we start to understand the complete user experience, and that's key to these metrics in the user state, right? I don't want to keep track of what's happening at the access point. I want to keep track of what's happening at each individual user. Now that's more expensive. I have to, you know, there's probably a ratio of 5 to 10 users per AP, so that's a lot more data I have to collect and process. So these are the next key part of what I call domain expertise structured data, right? So we were basically taking all this data coming from the access points and the mobile SDKs, processing it, and turning it into something that a wireless domain expert would appreciate, right? So these are all your pre-connection metrics, time to connect, fail to connect. These are all your post-connection metrics, throughput, coverage, capacity, WAN, AP uptime that you need. And in addition to that is the beginnings of classifications. If someone fails one of these metrics, you start to want to classify why did they fail, right? And that's part of the virtual assistant data science piece coming up. So this is laying the foundation for the next piece. Now we've got the data structured into metrics and classifiers that a domain expert can understand. The next piece of the puzzle is, okay, what about this? And this is really the tricky part here, right? And this is why the other thing I figured out of why little startups can actually beat companies like Cisco and Aruba stuff, right? Because when you look at the problem we're trying to solve here, I've got to get wireless guys, data sciences guys, and cloud guys to all play together and work with each other. That's very hard to do in a large organization where you're siloed. So to get this to work, all these guys to work together, and getting the data scientist guys to work with the wireless guys is not trivial, right? Because they understand the math, but they don't necessarily understand all the wireless stuff that's going on. But mutual information is kind of one of these data mining techniques. How many statisticians, anybody here familiar with mutual information? Right, so these are why it's worth doing this stuff, right? Because when you get mutual information, what it's really telling you is if I have two random variables, right? In this case here, right? Let's say that blue circle there is my time to connect random variable. And the red one is my DHCP response time. What mutual information starts to tell you is how relevant is that time to, that DHCP response to my time, how well does it predict my time to connect failure? And once you have that, when you see all this stuff up here, then I can start to answer questions of why, what is causing my client a problem, right? That upper right thing is, where does he rank in the clients? In this case here, this tells you it's a client problem, right? Of all the clients, he's an oddball. He's a high predictor of that failure. An SSD, an SSID problem because the SSID he's connected to is not a problem. So this starts to help you try to quickly sort out things like what is going on with my particular client. Anomaly detection is probably a key item in these data science toolbox that you'll need to get to know and love. Anomaly detection can come in two flavors. One is what I call feature discovery. This is like outlier stuff, right? You're looking for outliers, and you may have one of two features, right? I may have a timed connect variable, and I may have a feature like device type, right? And so we have several customers and people now. This is what helps you find out that your symbol barcode reader is causing problems, right? You may have 30 different types of barcode readers out there, and you're trying to figure out why one is the problem child. So this quickly pops up this barcode reader up here is causing me problems. He's an outlier. I need to take a look at him. The other key part of these toolbox is time series anomaly detection, right? In another key story, I had a case where, this was a funky case where he turned off the lower data rates, which is pretty common, right? You figure out, hey, I'm gonna make the world a better place, turned off the lower data rates. All of a sudden his time to connect metric just went sky high. We had students calling up, everybody was complaining. This is what I call the plane crash thing, right? It's weird combinations of things of somehow turning off that lower data rate set off a DHCP storm on the back end. And that was because his DHCP server was misconfigured. Instead of a unicast, it was configured to broadcast, and turning off those lower data rates caused this enough retries to push, the straw that broke the camel's back. But that's a case of where it would take you for a long time to put those two things together. These new AI software things will start doing that correlation for you, start pulling that up quickly to the top of things. The third example I'll give you is probably my favorite. This is my location example. This is where, when you started to solve this location problem, I spent probably a good 6 months just getting the antenna right on these BLE arrays, right? Because I wanted to try to virtualize the beacons and get machine learning to work. And to do that, I had to get the antenna pattern correct on these BLE arrays with my mobile device, listening to all these beams, and I need to sort out where I am at in space and sort. So what this is highlighting is, if you ever do this, the key part here is you want to look at the cross-polarization. The question, can you maintain these beams that look very good in an anechoic chamber, right? They look perfect. You take them out in the real world, where you saw these 20, 30 dB nulls, you no longer see them in the real, right? It all gets smeared out by multipath and polarization effects. So this was the key of getting the location problem into a machine learning format. This is the model that you need to machine learn, right? This is what everyone here does site surveys. See how many location people do I have? Anybody here work on location problems, site surveys and all that type of stuff? So this is what you're trying to learn. Constantly walk around trying to get this model straightened out and learn everything. The one thing I will tell you after working on this for the last year or two is, which wasn't intuitive to me, I would have thought that if you found the path loss model that best fit that curve, that would be the model that would minimize your location error. It turns out that's not necessarily true in the real world. And so this is the key part of starting machine learning here. The final key part is, once you got all this RSSI data, you need to turn it into a bunch of probability surfaces, right? And that is where what I call unsupervised machine learning starts to take place, right? Now the information I need is in that probability surface somewhere. And when you actually dig into it, what you'll find out, if you actually take, for people who are familiar with path loss models, if you take the PLE plus the intercept of your model, what that really is giving you is predicting you the RSSI at 10 meters, right? Because the log of 10 is 1. So adding those two numbers, predicted RSSI at 10 meters. When you actually start looking at that data, and you actually plot in this graph here, if you plot location error versus PLE and intercept, what you see here is what I call the valley of happiness. And in that valley is the PLF that you want to minimize location error. And that is, once you have that valley, and what's key is to make these unsupervised machine learning algorithms work, you eventually have to get it into this form initially. And if you're into this type of thing, you'll find out that if you start plotting that curve over there, is really plotting the metric versus the intercept on the bottom there, right? So you can start to see the valley. So as these PLFs push you out of the room, there's unbounded error, right? So you can see the curve goes way high, right? Because there's no limit to that error. If you start to get the PLF too low, it'll start to get down to the nearest 8, and that will limit your error. And what you'll find is, when you do this, you'll find that this PLF, this valley of happiness, can actually vary with location, and it can vary with device type. And so this is the importance of how these algorithms can actually help you start to do the machine learning. So now we don't have to do site surveys anymore. Now, it takes a lot of data and crunching, and 15, 20 years ago, I could not do this because I didn't have the horsepower. But the point of this is now we do have the horsepower, and this is why these AI algorithms are going to make a difference. And if you haven't looked into it yet, everybody in this room probably needs to start taking a look at how AI can make their life easier and better. Let's see. Does everybody remember Sudhir from last year? No one? All right. By popular demand, I'm bringing Sudhir back on stage.
All right. Good afternoon. If most of you didn't understand anything that Bob said, you're with me, because I don't get it either. So, but the good news is, all we have to do is leverage what Bob has built. We don't have to understand it. We don't have to interpret it. We just have to make our life simpler and easier. I know it was late. It was right after lunch, and we went into some deep data science there. So here's what I'm going to do. I'm going to show you how this translates into a product, right? That we all can start to use. And I'm hoping the video is actually working. Did my mouse move? Did anybody see? Yes, it moved? That means the video is playing. Okay, very good. So, quick introduction. Bob's actually the CTO, co-founder of Mist. I'm Sudhir Mata, I run the product management team for Mist. So here's what we're talking about. Every user, every minute, every user, every transaction, if the user makes on Wi-Fi, we can take, collate, and curate that data. We can solve a lot of problems. Historically, we've done a very bad job of keeping this data and actually using it, right? So here we are, we're taking every user's time to connect. Every user, every time the user connects to the network, we're tabulating that. Now, once I have this, Bob talked about metrics here. So once I have these metrics laid out, every user, every minute, one of our customers runs about 5,000 APs, 300 sites globally. They use that percentage literally. 87% of the time, their time to connect was good. But then, what about the 13%? That's important. That could be the CEO in the boardroom, the provost with the whatever, right? So then we go down into what is causing these failures. And that's what when Bob talked about data and then metrics. Metrics are our monitoring methods to become proactive. That 87%, it's a test network, but our customer networks, about 95% of the time, our largest networks are doing better than whatever time to connect they set. Now, for that 5%, is it DHCP? Is it authorization? Is it association? Is it the WAN? Is it the DNS gateway? What is causing that, right? So that's what we are monitoring here. So once we have that, they're turning their business proactive. Before the site calls them, operations teams calls these sites and say, something is going on, we're gonna take a look, you don't call us, we'll call you. Proactive networking on a per user experience monitoring basis, first time in the industry, right? So now, let's go into how do I take that data and dissect it further, right? So, time to connect, the curse in our industry is, a random dude could walk into your network, try to connect to the guest network, have a wireless experience, can tweet your wireless sucks and walk away, and you never had a chance to even look at his device. You can't touch his phone. How do we impact user experience when we can't touch a user's phone? Here I clicked onto an individual user's device. This is Frank Bauer's iPhone. Now for the first time, this is what we're launching at WLPC today for our global customers. We are able to do these SLEs on a per client basis. So far we've done it on a per organization basis, per site basis, per AP basis, and now we're down to an individual client level. You can monitor this experience. Why are we able to do it? Because we say there is one way to connect to the wireless networks and 136 ways you can fail. We collate and curate the 136 ways, and we store them in the cloud. So this is Frank Bauer's iPhone. We track all these states and much more. How can there be 136 states and Wi-Fi? You guys should be throwing shit at me right now, right? But there are, because DHCP could be lagging, DNS could be lagging. There is no state transition for delays, right? But we are tracking that. Here we are, DHCP stuck. I have a dynamic packet capture waiting for me in the cloud. So never ever do you have to tell your customers, hey, can you go walk that hallway again so I can take a sniffer trace? Passé, guys, passé. Don't do that. That's controller shit, bad stuff, old stuff. Now, the new stuff is, how do we get this kind of data? How do we get this kind of data to help us segment across device types, device OSs? Is Marshmallow good for me? Is 11.1.2 good for me? 11.2.6 is out. Is that good for me? How do we take one of our customers here, potential customers has 300,000 Android devices on their network. How do they make the decision on if that device type is good or bad, the next version is good or bad, right? We will tell you on a per AP basis, on a per site basis, exactly where in your network roaming is bad, right? A simple map to say, hey, where on my network is roaming bad today? Try doing that with a Cisco Prime. Sorry, I didn't mean to say that. So throughput is a predictive metric for us. Throughput is a predictive metric because we actually, it's a composite metric. We bring a lot of things together. Anyway, I always take an hour's worth of content and put it in 10 minutes. That's why I talk so fast. Here's the world's first wireless virtual assistant. So what does a wireless virtual assistant do for us? What it does is it helps you process natural language questions. Right? When help desk has to answer questions that they are, a zoology major trying to take a call in a university, how do they get to, hey, what's wrong with Randy's iPhone? Can you just simplify it for me? We've integrated an NLP processor, NLP system into our virtual assistant. And then you can, once you ask the simple question, it does a few things. It tells you, hey, Randy's iPhones, the top 3 issues are, roaming and connectivity, whatever. And then it does one very important thing. Mutual information, if you don't know what it is, please study on it, because I had to keep my job at MIST, is foundational. You spent 6 months building that one sentence. That one sentence is 6 months of data science work. Is the problem specific to that individual device, or is he a victim of a systemic issue? Where do you start troubleshooting? Do you start at Randy's phone every time he calls? Bad idea, right? You should actually find the highest place of aggregation where things are failing, right? So here we are. I'm able to click down into, once you say, okay, you said roaming was the issue or successful connects was the issue for Randy's phone. Show me the proof. We can actually go down into every individual stat here and say, on average, Randy's phone is taking whatever, 7.5 seconds to connect. That's absurd. It should take 50 milliseconds to connect. Now we go in, is it the DNS gateway not responding? Is it association? Is it DHCP? We do the correlations for you. The systems should do the correlations for us. It's 21 years after Wi-Fi is born, enough of manual stuff already, right? So now let's do the correlations across as many vectors as we can. The plans, the APs, here we are looking at, if somebody changed RRM, if RRM changed channels, if somebody changed config while I was messing with this network, could that have caused this guy's degradation, right? And then, if all else fails, we'll give you a full, complete event log of this individual guy, including a PCAP if there is something catastrophic to his experience, right? This is the modern cloud. So now, can it only answer an individual question? It actually can answer questions way beyond that, right? So let's say you ask the question, hey, I have this site and the store manager called me and the store is always having Wi-Fi, right? How do we get to the bottom of that? Well, ask Marvis, right? So now you say, what's wrong with this site? It will do that mutual information correlation and come back and say, we believe what is wrong with this site as of last week or whatever is 3 things. We are doing the correlation for you. IBM Watson took probably 4, 5, 6, 7 years to build. We are on that journey. Will we get our answer right in 1.0? Probably not. Maybe, Bob, our goal is 30%, 30, 40%?
30, 40%.
Yeah, and so we're going to get there. We're not ready to package all of you into a system and ship it, but that's our mission. Why? Because wireless networks are only growing faster and bigger and more, and we need to simplify to survive, right? That's our mission. The virtual wireless assistant is not a cute NLP exercise. It's not a cute, graphing exercise. It is to simplify wireless as we know it forever and change the world, right? So now, this is at a site level. We're talking about all the changes. We can tell you exactly where on the site something is failing. Again, we are intensely focused on solving one problem, and the one problem is anything that's connected to Wi-Fi. I don't care about, if your switch is flaky, if you have whatever other loops on the wired network, we're solving, we're the next generation of wireless. Here's other questions you can ask, my favorite ones, right? List clients that are iPhones that are Model 7, right? Somebody will call and say, I don't know what this thing is, right? So here you are. You can ask the question, and it'll then filter this 96 clients and say, okay, you have 7 Model 7 or 31 Model 7 iPhones. I want to know how many of them are actually 11.2.2. How many of them actually upgraded? Well, there you go. You have 9 of them. And then you can go in, oh, okay, so you don't know what is a MAC address. You just need to get your Wi-Fi working. We got it. We don't need to know what MAC address is, right? So we can go down and find somebody's phone here, be able to troubleshoot it, right? So the idea is, we took 2 years to build a cloud platform that can ingest data every 2 seconds from every site in the world. And then an year to build metrics that are meaningful. And now we are overlaying on top a data science platform that is horizontal. What Bob talked about, candidly, in my English speak, is 3 things. First, can you correlate it? Second, can you do the machine learning on location so I don't have to do manual site calibrations? How do we do that? And why do we do that? Because an iPhone 7 behaves wildly differently than an iPhone 6. And then if you take an iPhone 6, it behaves wildly differently at your home versus at a Home Depot. The ambient RF has all the impact. We can take that and we can machine learn the path loss formula on an aisle by aisle basis, on an AP by AP basis in your stores, right? This is the power of applying AI and machine learning to solve problems that always existed. And none of the use cases we are talking about are solving here are net new. All of these use cases existed for a long time. Our mission is to make your life maybe just a little bit simpler. Thank you very much.
So while they go back and swap their mics for Matthew to come up, while he's bringing up,